Hello everyone. Today we're going to be looking at 4.2, solving linear inequalities. So you should have your handouts ready. Okay. You can also have graph paper ready, or you have Desmos or a graphing calculator. Okay, so on your handout I asked you to graph y equals 4x plus 5 and y equals minus 4 on the same grid. So I know we did solving linear inequalities before in Unit 1, but now we're going to look at it in terms of graphs and polynomial functions. Okay, so solving linear inequalities is actually finding the point of intersection of the two functions, and you're going to decide, depending on an inequality, where on the x does one function greater than the other or less than the other. Okay, so if you took a look at the graph, so what I did, I just graphed the two lines together on the same grid. Let me just pull this off. There you go. So the purple line is y equals 4x plus 5, and the red line is y equals x minus 4. So we just want to know, as the question is saying, when is y equals 4x plus 5 less than x minus 4? So when is it 4x plus 5 less than x minus 4? Okay, so as you can see, we can look at the point of intersection here. So at -3, -7, looks like that's where the point of intersection is for those two lines, right? So as you can see, to the left of that -3, you see how the purple line, y equals 4x plus 5, is lower than y equals x minus 4? Then we know then from the left to the left of -3, right, to negative infinity, that's where the two functions, that's where y equals x plus 5 is less than x minus 4. So when x then is less than -3, 4x plus 5 is less than -4. Okay, so we're just going to look at that algebraically in a moment. Okay, we're just going to take a look at the handout and fill in the words and the work. Okay, so here it is. Okay, so as we know from before, solving linear inequalities is just like solving linear equations, but when we multiply or divide by a negative number, we change the direction So when we multiply, actually I'm missing order, when we multiply or divide by a negative number, we change the direction of the inequality. Okay, so just to go over that example that I just had, that I graphed, you got 4x plus 5 is less than x minus 4. So what we're going to do, just like any good old equation, we're going to get the x's on one side. So we're going to put 4x minus x. Okay, so again, follow the same conventions. When you're switching sides, you switch signs. So -4, -5, so this is -9, we get 3x. Okay, since we're not dividing a negative number, right, we're not dividing by a negative number, we're just going to keep it the same direction, cancel the x's, x then is -3, and that's what we had before. Okay, now when we write it, the set notation, okay, so we go x is an element of R such that x is less than -3. So in that set notation with the parentheses or the curly brackets, okay? Interval notation, so as you remember, involves two things, two items, right? So you're either going to have round brackets or square brackets, okay? Now it all depends on the inequality. Since we have less than and there's no equal sign, we're going to use round brackets, right? So if it's less than -3, right, it basically means it's from -3 to negative infinity. So negative infinity is only on the left, and then negative 3. So we're going to use round brackets because we don't see any equal signs. We're not going to use the square brackets. Okay? All right, for the number line, how would this look like? So let's just scroll down for the number line. We're going to draw a line. Put numbers, so let's say negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, and so on. Okay? So, since it's less than negative 3, no equal signs, we're going to just make sure we have an open point, and then we have the arrow pointing towards the left. Okay? All right, let's take a look at the next page. So I'm just going to pull out that file. Okay, so you have 3x plus 1 is less than and equal to 5x plus 9. So let's get all the x's on the left side. So let's just put 3x minus 5x. And then 9, the 1 moves over to the side, becomes a negative 1. So now we have 8, and this is negative 2x. All right? Now, in order to get x on its own, we have to divide negative 2x and 8 by negative 2. Since the divisor is a negative, we're going to switch the inequality. So that's less than or equal to. Now we're going to go greater than and equal to. Okay? So we know we divided by negative 2. Final answer then is x equals negative 4. Okay, so in set notation, start off with the parentheses, x is less than, or x is an element of R such that x is greater than negative 4. Okay? Interval notation, since we have an equal to sign there, that means we're going to require round and also a square bracket. Okay? So we're the negative 4, we're going to have the square bracket there because it includes negative 4. And since it's greater than, we're going to have a positive infinity. And we never put square brackets next to any type of infinity. Okay? All right, for the number line. So let's just move up. Just get your number line. Okay, so let's just put negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0. Okay, since there's an equal to sign, we're going to have a close point on negative 4, and then to positive infinity, so it's greater than. So it's the arrow points to the right. Okay, so that's set notation, interval notation, and the number line for x is greater than equal to negative 4. Okay, now on to the last page. We're going to kick it up a notch. Just pull this up. Okay, so we're solving an inequality where it invokes two inequalities. Okay, so whenever we see brackets, again, just like any good old equation, we need to expand and simplify. So we have 5. Let me just use actually the black one. So 5 is less than or equal to 2x plus 6 minus 7 is less than equal to 19. All right, so now we're going to simplify further. 2x minus 1 is less than or equal to 19. Okay, so I see we have two inequalities here. So we still need to get 2x on its own. So what we're going to do then, we're going to get negative 1 to go to the other side, and then negative 1 to go to the other side, right? So on either side, actually. It's the same idea. Whatever you do to one side, you're going to do to the other. So this is now going to be 2x. If I'm moving a negative 1, becomes a positive 1. And I'm going to do the same thing to the other side. So this will be 5 plus 1. So this is 6, this is 2x, and this is 20. Okay? And we're dividing each side by 2 to get x on its own. Okay? We don't need to worry about changing the direction of the inequality because it's a positive coefficient. So now we have 3, and this is 10. Okay? All right, it's the same idea. We're going to do the set notation since we've got endpoints from 3 to 10 and there's equal to signs. We're going to use square brackets. So 3, between 3 and 10. Okay? Oh, sorry, that's for interval notation. For set notation, actually, let me just make that all clear here. I did interval notation first, so I'm going to put 3 and 10. All right, set notation, same idea. X is an element of R, but we've got X between 3 and 10, inclusive. All right, and a number line. Okay, so let's just do, let's say 2, 3, 4, 5, 6, 7, 8, 9, and 10. And if you want to extend that further, okay, oops. Okay, 11, and so on, right? So this is just sketch. You should be using a ruler. Okay, since we have equal to signs, close points on 3 and 10, and we connect 2 points. All right, so that's solving linear inequalities. Okay, so the textbook work is right here at the bottom of your handout. Okay, thank you for listening and see you in class soon.